number 1 here. The f of x is equal to 5 plus the integral from negative 3 to x of t squared e to the t dt. Find an equation of the tangent line to f at x is equal to negative 3 here. Okay, equation of the tangent line, we need two things. We need a point and we need a slope. How do we go about doing this? Well, for the point, we've got x is equal to negative 3. F of negative 3 is 5 plus the integral from negative 3 to negative 3 of t squared e to the t dt. And integral from a to a of any function here, for our purposes, is going to be 0. So this is just 5 plus 0 is, oops, there shouldn't be a smudge there. There we go. So 5 here is the output. So our point here is negative 3 comma 5. So the much more interesting thing in this problem is, well, how do we go about finding the slope of the tangent line? Slope of the tangent line is, of course, going to be the derivative of this function at x is equal to negative 3. So f prime of x is going to equal the derivative of 5 is 0. That's a constant, plus the derivative with respect to x of the integral from negative 3 to x of t squared e to the t dt. Now, this might look like a difficult problem to evaluate. So I'll just say if you are going on to take Calculus 2, within a month or so in Calculus 2, you'd learn how to evaluate this integral. It's integration by parts. But we don't have to do that because this is fundamental theorem of calculus going on here. And so when you have a derivative with respect to x of an integral running from a constant to x of some function of t here, dt, let me call this f of t is t squared e to the t, this derivative just ends up being plug in x in for t. And so our answer here is going to be plug in x in for t. The lower bound of the integrand here, the integral does not mean anything. So x squared e to the x is equal to f prime of x. And so then f prime of negative 3 is going to equal negative 3 squared times e to the negative 3. So that's 9e to the negative 3. So at this point then, to finish off the problem, we can write down our final answer, which is going to be, so y minus y naught is 5 is equal to our slope, 9e to the minus 3 times x minus x naught, x plus 3. So this is a fundamental theorem of calculus problem here, this version of it. There will be other problems. It will be a little bit more complicated if we have a function of x up here, not just x. There will be a later problem about that. Okay, that was problem number 1. Let's take a look at problem number 2. And so we're given f is continuous on the interval from 0 to 8, has a bunch of integrals here. Okay, so what can we do with this? In part A, we're being asked for the integral from 0 to 5 of f of x dx. Well, here's the thing. Integrals at, remember we're thinking of integrals as the area interpretation. Let me put down 0, 3, and 5 here. The area under the curve from x equal to 0 to x equal to 5 is the area under the curve from x equal to 0 to x equal to 3 plus the area under the curve from x equal to 3 to x is equal to 5. And so we can put things together in this way. The integral from 0 to 5 of x f of x dx is equal to the integral from 0 to 3 of f of x dx plus the integral from 3 to 5 of f of x dx. And we know this is 2 and this is 7. So our answer here is 9. Okay, part B is asking us about the integral from 5 to 3 of f of x dx. Well, what's going on here? Well, we have the bounds on the integral in the quote-unquote wrong order. And so a property that we should know is that we can interchange the bounds here at the cost of introducing in a negative sign. So integral from b to a of f of x dx is equal to negative the integral from a to b. Flip the bounds, the order, throw in a negative sign. So this is equal to the negative of, we already have this up here, negative 7. Okay, what is up next? We have the integral from 5 to 8 of f of x dx. Well, let's take a look at here. I'm just going to extend this a little bit further. This picture right here. So the integral from 5 to 8, this blue region, we can find it by computing the integral from 0 to 8 and then subtracting off this part of it. So this picture shows that the integral from 5 to 8 of f of x dx is equal to the integral from 0 to 8 of f of x dx. But we don't want this in here minus the integral from 0 to 5 of f of x dx. We could, if you're unconvinced by this, rearrange this and you have move this to the other side. You'd have the integral from 0 to 5 of f of x dx plus the integral from 5 to 8 of f of x dx is equal to integral from 0 to 8 of f of x dx. So then we know both of these. This one here is 15, and this one we found earlier is 9. So our answer here is 6. Okay, that is part C. There's one more to go here. Part D is asking us about the integral from 3 to 8 of 2 times f of x minus 6 dx. So the first thing I'm going to do is I'm going to get rid of all of the stuff that isn't directly relevant to the f of x here. So I can break up this integral into 2 chunks. So one chunk is going to be the integral, so negative 6 here, the integral of 6 minus the integral of 6. The other one's going to have an f of x in here. And also the 2 here, I'm going to move the 2 outside here, the integral. So we're using linearity properties of the definite integral here. We break this up, we move the 2 outside here. So this is what is going on. Okay, so now we have to do 2 things. We need to evaluate this integral, and we need to evaluate this integral. This is a very straightforward integral to evaluate because we know this is just a constant being evaluated over some interval. And so the answer here is just 6, minus 6 times the length of the interval. And 8 minus 3 is 5. That's where that comes from. Okay, how do we come up with now the integral from 3 to 8 of f of x dx? Well, let's just go back to this chart here. We want the integral, we want this part of the area here. Well, we can find this by taking the integral from 0 to 8 and then subtracting off the integral from 0 to 3. So this minus this will give us this. And we know the 2 things that go in there. So it's going to be an integral from 0 to 8 of f of x dx minus the integral from 0 to 3 of f of x dx. And this is something that we were given. That's 15. And this one right here is something we're given, that's 2. So 2 times this difference here minus that 30, this is our final answer.